All right, here's Guillaume. Cool. So let's get this started. So welcome everyone. This is Stateless Implementers call number 46. We are January 12th. I shared the agenda in the chat. It seems we might have Vitalik today join in to present one EIP, but in case he doesn't join, I think Guillaume will.
Oh, he's here.
I'm here.
Oh, there you are. All right, good. Since you're here, Vitalik, I would prioritize your time and have you present the EIP as the first agenda item, if you're fine with that.
Perfect. Yeah. Did you want to get the doc into the chair?
Do that, or at least I will attempt to. No, that's not the one. That's the one. Yeah. Oh, refresh. To my Windows. Here we go. And where's the? Oh, here it is. Okay. Share screen. Yeah. There you go.
Okay, great. Is everyone seeing the screen share? Okay.
Yeah. User associated storage.
Yep. Okay. Perfect. So the idea behind this is this new category of storage that I'm proposing, which I call user associated storage. And the idea is basically that a contract, and the easiest example to think through here is like an ERC20 token, can create storage which is associated with some user and ideally lives with that user in some sense. But it's still controlled by that contract. And so even though it lives under the user's header, the user cannot choose what to write to it, which makes sense for balance because you don't want users to be able to just give themselves coins. And so the goal of this is that it's more friendly to basically any kind of state expiry or state cooling, which is what I've been calling these proposals that expire state, not by fully deleting it, but by moving it to some place which is still accessible, but accessible with more difficulty or more lag. And the reason why it's more friendly is basically because all of these proposals benefit when state that is beneficial to a particular user all expires together and all can be revived together. And in addition to this, it actually also allows users to save gas. Basically, it reduces the amount of branch queries that you have to do by one. And so it could make things like 2000 gas cheaper. So the basic idea is that we create a new map, user-associated storage, and the map maps basically, so creator, user, and index, so that's the key, to 32-byte values. And then, so basically it's like a mapping, except we're basically taking the concept of a mapping and we're moving it in protocol. The other thing about this is that there are two places in the tree where this storage can be saved. So this is all assuming the binary tree design, right? And so basically, one of those two places is kind of default storage. And default storage is like this, and it's basically a random place in the tree, very similar to how contract storage is just stored at random places in the tree. But then the other option is basically that the user has the ability to promote a limited number of their own storage, these user-associated storage positions to live in their account directly in their account header. Right, so the way that the binary tree EIP works is basically that it's the bottom of the tree is these 8K pages. And I mean, I think by the way, we should still benchmark this and explore reducing the pages to 4K or 2K. This whole thing is, originally designed to be both. It was both a holdover from the Verkle era, where more width is good, and was designed for database friendliness. But we should make sure the width is actually database friendly. And so there's a lot of slots that can be loaded with one single disk read. And in the current design with 8K, you have 63 positions for the header. Then you have 63 positions for the storage. And this is really nice because, like, for example, if you're like I remember I was looking into Uniswap v3 and just every transaction reads like 8 storage slots. And so 20,000 gas will go down to like 2,000. And then also the first pile of code chunks. And so if you have small code, it loads all at once. And I'm suggesting we kind of squeeze in basically these privileged UAS positions. And the idea is basically it's like a list of 16, and it's just a key, value, key value, key value, key value. And a reminder that the keys here are basically that you take like basically the hash of the account and the user, and then actually what we're gonna do is basically prepend to that the index, and the index just lets you have 256 of them, and that just makes it easier for an account to have, like for contracts to have multiple mappings like this. And so basically what you have is you have this kind of promotion mechanism where basically as a user you have this opcode, and effectively normally your UAS slots would just live in random positions in the tree, but what you can do is at any time, hopefully even before you get those coins, you can like call this opcode, and the opcode kind of promotes the location where it gets stored to be in the header. And then when and it also kind of demotes the old thing and moves it down, right? And then you add these opcodes, kind of US store and US load, that basically read or write the storage in the right location, right? So US load would basically first check in the header, and then if the key isn't one of these privileged values, then it would read in the global state. But if it is, then like it just reads the header and it stops there. And then one thing is in this EIP, I have this mechanism where basically you use like address mod 16 to choose which position in the header. And so that means you only actually have to read one position. There's like a couple of different ways of how to implement this. There's like small trade-offs, but basically it means like you have to do only one read of one chunk. That's like basically the whole thing, right? And so the way that this would get used is, again, basically, imagine that like this account is like, for example, your account, and the contract that's creating the UAS is some thing, could be an NFT, could be an ERC20 token, like let's say it's your Shiba Inu balance. And then what you would do is, as a proud Shiba Inu holder, is basically, you would call set privileged user storage once, and then that would set one of these keys to be the Shiba Inu address. And then when you receive Shiba Inu coins, what the US store would do is it would first look at that position, it would check that the key matches, and it would just save them in the header. And then when you do a get balance, you would just read them from the header. And so basically, if you're any kind of user who only touches a few coins, then like almost always you would like basically just be doing everything entirely from your header. And then like you would also have to touch the code of the Shiba Inu contract, but like those are the only two things you would ever actually have to touch. So that's and again, like from an expiry standpoint, it's basically really nice because effectively, at least for that like subset of users, which I think is large, and which I think with like proper privacy practices will only get larger, like you only have a few coins. And so like this entire thing could just be expired together and then revives together. So yeah, that's it.
Thanks. Is there any question? I have a few questions, but maybe the audience does too.
Yeah, I have a question. So let's take this like chart here with header values and storage slot. So let's say we are dealing with an ERC20 like Shiba Inu. So the user would itself, like the owner of the token balance, let's say I have Shiba Inu, I would myself call set privileged user storage on the Shiba Inu token, allowing it to write on my own local storage, effectively treating like this balance on equal grounds with a normal Ether balance, right? So it's a way of promoting that up to my own account storage. But then this lives under, I guess I'm confused as what lives on the Shiba Inu contract, that like purple part, and what lives on the my own.
Okay, so everything in this diagram lives under your own header. So if once you've promoted the address, then the only thing that lives in the Shiba Inu contract with respects to you is basically the Shiba Inu contract code.
Okay, fair enough. And all storage lives under. So anytime when I want to call my Shiba Inu token balance, would I call? I would still call the balance of.
Yeah. So technically, the way I designed the US load opcode over here is that it actually has a flag is user, and so you can read your local storage either from your own account or from the Shiba Inu contract.
And would that require smart contract changes on behalf of the Shiba Inu token so that there's a like initially it would use uStore if available.
Yes.
Otherwise it would fall back to its own contract storage, right?
Right. So this would require token contracts to change and to start using US Store. Fortunately, it does not require any changes to the ERC20 standard.
Yeah. Good. Cool. That clears up my question. Thanks.
So technically we don't actually need to use binary try, right? We can also apply it to the current MPT. So I mean, we don't have to wait for binary.
Yeah, that is true. Though I guess the one thing is that would require kind of opening Pandora's box on like changing the number of objects in the header, and I've been told that this is non-trivial.
Yeah, and there's also the question of how you handle the transition. I mean, I'm sure it's just about writing the tree, but yeah, it's one extra thing you need to translate. I mean,
technically you don't need like any kind of full sweep because it's like empty by default. But like you do need to suddenly give clients the capability to treat the header object as something that has like the 36 fields instead of 4.
Yeah, but what I was more thinking of, you've got your promotions and your demotions. If one of them is has been converted to the new tree, but the other is still in the old tree, I mean, I'm sure it's doable. It's just I don't really want to be thinking about this. That's my
right. Yeah, that's fair.
Any other question?
Would you say that the main benefit of this is just having an easier pathway toward state expiry, or is it just gas reduction? Like, what do you see as the main benefit?
I think for me, both are interesting. I think like in a world where we adopt stronger forms of state expiry, I think the state expiry friendliness becomes more meaningful. But like in worlds where it's, even in worlds where we adopt kind of things that are closer to the leaf-based state expiry ideas that Guillaume and the others have been supporting, then like effectively, the user's header becomes one leaf, and so that it also becomes very convenient. In worlds where we do something more non-invasive than or nothing, then it matters less, and the gas cost reduction starts mattering more.
Okay, thanks. That's all for me.
Okay, so I have two questions. One of them, I don't, at least if you answered, I didn't see it. Why don't we put compared to the base design where we had 128 code chunks? Why don't we put this the US privileged US zone? Why don't we put that in the reserved position? Like you have 0 to 66.
Oh, I see.
You have 62 slots that are currently reserved.
Yeah, I think we can. I think that's a totally valid choice for us to make.
Okay, and the second question is, when do you see this being shipped? Like we have this roadmap, which most people in this room haven't heard of. But when would this happen? Like with the binary tree, potentially before, but or with state expiry, which
Right. I mean, I think intuitively, with the binary tree is very natural. I think like the big challenge with doing it before is that you basically have to write the code for both the before version and the after version, and even the transition, and then figure out pre-images for the transition, and it's more code. Doing it after state expiry, I don't think makes sense, because I think if you're going to make any IP that makes it harder to do things with old state, I feel it's only right to give users access to a mitigation. And so basically, somewhere in between those two. I mean, for me, it's anything is fine. I think the nice thing about the binary tree design is that there's this kind of get tree key mechanism that actually makes it easy to just throw in new kinds of storage to represent pretty much everything, and it just all lives in one blob.
Right. So yeah, potentially we could have it right off the bat at the binary tree transition. Okay. One detail I'm a bit fuzzy on. So there's a maximum of 256 UAS slots.
Here 16.
Privilege, yes, but
privilege. In total, yeah. So 256 per account. So effectively, I mean, theoretically, it's probably this basically means that a contract can have 256 of these user mappings. And theoretically, if you want more than 256, you just work around it by making child contracts.
Okay.
Yeah, theoretically, of course, with regular storage, you can just do whatever you want with mappings. The challenge here is the protocol needs to be aware of the fact that the storage creator is a particular contract, and then the storage key is a user.
So if we don't use any of those things, the default behavior is we fill all the slots. Then what happens? It's a failure, it's a revert.
I see.
Once it's filled, and that's it.
Basically, what happens is that the only way these 16 get filled is if a user calls promote, right? And so if let's say, for example, I get Shiba coin, and then Shiba coin is assigned to slot 14 because that's what the address mod 16 is.
Yeah.
And then let's say Shiba goes to 0, and I stop caring about it, and then some other token I don't even know, Mudeng coin comes up, and it turns out that Mudeng coin is also 14 mod 16.
Yeah.
Then in this design, I as a user basically have to make a choice, and I have to either privilege one or privilege the other. And then the one I don't privilege is going to cost more gas, and it's going to be more annoying to revive.
Right. But if Muden, you call it?
Yeah.
If Muden and Shiba are also the same value, modulo 256.
Right. Oh, I see. This is in the version where we do cuckoo hashing, basically, right?
Right. Yeah.
Right. Okay. Then again, you would also be forced to deprivilege one of them.
And so you deprivilege one of them.
Yeah.
And in that case, but it's not one overrides the other.
Yeah, no.
Okay.
Basically, basically when you deprivilege, all that means is the place where the storage lives just kind of goes back into its regular location. And then when you do a read, you would basically read the header, and then it would see, this key is not representing Mudeng, now it's representing Shiba Inu, and then you would fall back.
Okay. Yeah, understood. Okay, cool. Carlos?
Sorry, I arrived late, so maybe this was already said, but is this first come, first serve for transactions that I receive, or does the user actually need to do something to actually allow these token coins to get the privileges?
Yeah, so the user has to call this set privileged opcode. And the reason why we have to do this is because otherwise, spam tokens could privilege themselves.
Exactly.
It would be annoying. I basically arguing that we'll have account abstraction by then. Even with 7702, it's just it's easy to just throw the privilege into whatever call that's inside any transaction you make.
Okay.
Yeah, that makes sense. Okay, so that might sound quite familiar to the people who are aware of OOPSI, but this I assume mainly makes significantly easier to anyone to store their account data plus their token balances on a way in which they don't constantly need to fetch contract updates to see if their balance changed. Is that correct?
Yes.
Okay, so we finally have a way to do state expiry, but without the burden of killing accounts, which are really hard to recover for balances of tokens, which are not pure ETH. Okay, that's nice. Thank you.
All right. Any other questions?
Hmm.
All right. Then thanks a lot, Vitalik, for presenting. Is there, oh, it seems
Sorry.
Han and
Yeah.
Carlos both have their hand raised.
Okay.
Carlos, you want to go first?
No, sorry, it was a leftover from previously.
Okay.
Thank you.
All right. Go for it, Han.
I think I'm just thinking out loud here because this issue is nice, but definitely that has a restriction of having limited number of like user associated storage. So this might sound like a stupid idea, but is it possible for like contract bytecode to be redesigned in such a way that if there's a mapping between an address to some arbitrary value, we would store it in the storage space of accounts rather than the storage space of the contracts itself. So that means we'll be expanding on this UAS to not just 256, but more than that.
Yeah, I mean, effectively, this is doing that, right? Like, this is creating, like, basically, yeah, again, like locations in the tree that are so I guess they're not like the binary tree is uniform, and so like storage is not like live under a user's account, but it's like if it's effectively in an index that's bound to the user.
Why not then just use the existing storage slots for the account that are unused for EOAs?
Yeah, I mean, you could. I don't like existing storage slots. I mean, it ends up not being different. I think like that would just create more like logic for like it would create more awkwardness for differently supporting EOAs and smart contract wallets. And like basically, yeah, the thing that you would end up saying is like, oh, you'd have to like come up with a different hash prefix to deal mean separation between this kind of user storage and the other kind of user storage. And like effectively, that's exactly the same as this.
Yeah, that's fair.
And wouldn't that clash with potential 7702 slots?
Right. Right. I mean, if you like directly use storage, it would. If you do, yeah.
Right.
If you do this, it doesn't.
All right. Any other question or comment? All right. Thanks a lot for taking the time, Vitalik. So, I mean, you're free to stay here, but we'll proceed with the next element on our agenda, which is team updates. So, whoever wants to go first, feel free to get started.
I can. So this last week and this week, I've been mostly focused on two tasks. The first one is trying to unblock ACDE by getting benchmarks on 7907. I've built a ton of stuff, but the issue is that I was getting cached results from Geth. So I spent quite some time with Gary discussing how to approach this. And now I basically nuked my mainnet DB to actually use it with Geth in development mode and be able to take all of these benchmarks. The bloating of the setup is almost done. So I think by tomorrow I should have all of the results, and the plan is to publish it on ETH Research, and if needed, present it very shortly on ACD this week. The other part is I've been working with another guy from the EPFL, I think it's called, something like that. On basically the second posts on the feature of the state that I did, specifically on a formalization on how the partial statefulness will work when you look at the tree. So we're trying to integrate it within vals, computing the worst cases for vals, which would be EOA transfers from non-empty to non-empty accounts, where this is the way in which you can actually get the least amount of storage written and the biggest amount of bytes put or dumped into the block access list. But so far it doesn't look bad at all. So we are finalizing the specs and everything, and the idea is to push another post, and then if I get some green light or people see interest on being able to run these partial stateful nodes, the next thing should be probably coding something, a prototype that actually basically is able to run, provides RPC responses, especially ETH-get proof, which is what I'm the most interested on. And on the top of that is only storing a very minimal amount of storage, something likely like VOPS requires. So we could kill 2 birds in one shot by actually having the VOPS functionality to maintain the mempool and at the same time having the partial statefulness functionality also. So yeah, this has been mainly my last week and a half.
Thanks, Carlos.
I can give a quick update, but just want to share a few things on what we have done with the ETH team. So I'll just quickly share my screen. Yeah. Okay. So basically, I would like to introduce this page in ETH the lab page. So basically, you can everyone can see the state growth visualization here. So I mean, this data is extracted from a Geth node. So definitely, if you compare it with your EL node, it's definitely different. But at least we can sort of see like the trend of state growth over time. So yeah, that's one page on state growth, and then there's also another page on state expiry where we are exploring like what happens if we do different expiry policy. For example, this one is at 1 year. Like we only keep active state for 1 year, and this is 2 years. Then how many storage slots will be deleted or reduced? And same goes to like contracts, and later on we also have accounts. So yeah, there's a few things that you can explore, and also there's also the top 100 contracts by storage size, which the first one is definitely Zen. I mean, that's pretty obvious. But yeah, so yeah, just want to quickly share on this, and we are still validating the accuracy of the data. I think for state growth, it should be fine. Contract codes is slightly inaccurate by very little. Like this should be like 2008 something. But yeah, for state expiry, I think we are trying to validate the data, and same goes with the contract. But you guys can take a look and give us some feedback on what you would like to see next. So that's all. Yeah.
Great. Thanks, Han. I noticed at the end of the graph, there's a small spike. Is that intentional? I'm just looking it up locally, and I see that the data stops at like September 22nd, and then it jumps in January. Like what's...
Yeah, that's the backend refactoring part, because there were some issues with the bytecodes data. So the ETH team trying to rerun the backend thing, and I think by the end of this week we should have the accurate data. But yeah, it's mostly
okay.
data.
So it's just a data issue. Cool.
Yeah.
Thanks, Han. Anyone else or team updates?
I guess I can talk about what I did since the last call, which was a long time ago. There's been 2926, right, which was DFI'd. But nonetheless, I've been talking to a few teams about this, and the next challenge is to address 797 and try to not getting scheduled, and instead just replace it with a proper just a code size increase. So yeah, to be continued during an XACD. Otherwise, there were some roadmap discussions and still are roadmap discussions in Berlin. So I'll have a quick update about this. Basically binary trees are back in full force. I was discussing the topic with Karim, who's not here today because he's on holiday. But we're going to make a push for that, and it will become more apparent why. But yeah, that's general. That's the update. Yeah, Carlos.
I just wanted to point out that independently of whether 7907 happens, notice that there's going to need to be some EIP if we decide to go with the code size limit increase, because with the Fusaka transaction gas limit, it's actually impossible to deploy any contract that is bigger than, I think it's 80 kilobytes. So 128 and 256 are completely out of the page. In fact, I wasn't even able to benchmark them. I've been only being able to benchmark up until 64. I could guess even more, but at this point it's getting tricky. So yeah, just to point it out.
Okay, I'm not sure I understood actually. So you're saying, okay, I understand you can actually deploy 80 kilobytes.
Even if 7907 doesn't make it, if we want the code size limit increase, we will need to have an EIP no matter what, because we need to actually allow contracts bigger than 80 kilobytes to be deployed. And the only way to do that is if we add something into the protocol that says we can jump over the transaction gas limit only if we are deploying. I mean, something along these lines.
Okay.
And this logic needs an EIP. So
but
even if it's not 7907, we will need to do another EIP that basically says that.
But if we bump the size to 64 kilobytes, we would not have this problem.
Oh, yeah, but I mean, I was assuming that people is pushing to 256 for some reason, not just choosing a random number. But
there's like a two-dimensional chart here, right? Because I think there's also the goal in GLAM of bumping up the gas cost of creating new state. And so effectively, like the idea this year would be that like we'd increase the amount of execution gas by 10x, but we would increase the amount of the state creation rate by like only 3x, or hopefully. I mean, or maybe if people end up being conservative, even a bit less. And the math is basically like if you increase the new creation cost by 3x, that means 600 gas per byte. And at 600 gas per byte, every 10,000 bytes is 6 million. And so with the current stats, you'd only be able to get up to like basically about 27,000 gas. So effectively no increase at all. And so the realistic options on the table are like some combination of one, accept that and give up on doing contract code increases in GLAM, but maybe do them in H-star. Two is temporarily bump up the per transaction gas cap. So like, for example, if you do a bump up to 32, then you would be able to bump up the, like you would need to bump up the per transaction gas cap to 20 million. And so it's like modest on both sides, and then the third option is like, basically, figure out some kind of multi-dimensional limiting. And that's like hard because it's sort of invasive in the EVM. It's not like a clean thing like call data, because even for creation transactions, the code that gets created is ultimately generated inside the EVM. Like it's not just like a raw field of call data. And so like that stuff is doable, and like there's a lot of mood to go toward multidimensional gas, but like intuitively to me, it doesn't feel like a GLAM thing.
okay, that's fair. Yeah, that's fair point.
Guillaume, do you want to continue with your update, or are you done?
Yeah, I'm done.
All right. Thanks. Anyone else? Maybe someone from testing?
I think Carlos already reviewed that one, but I think another look would not hurt. I think the main discussion point, let me share first the link just quickly. This one. Just 1 second. This one. I got already a review from Carlos. So this is basically based on a PR that he prepared already. I think the main question here is how do we approach benchmark tests? There are two approaches at the moment. Basically, the gas introspection one, where you decide when to stop benchmarking the state opcodes, or whether we pre-compute how many iterations the test does in one transaction. I really like to pre-compute everything, so we have like a more certain approach. And if anything changes in the future, for example, if we reprice something, that will definitely not break tests. Whereas if we change the prices and for some reason something doesn't work anymore, we will not catch this if we are relying on the transaction to do all the work by itself and stop whenever it wants. But yeah, I think I don't think I'm missing anything from you, Carlos. Do you have any comments on this PR?
Not on the PR in particular, but on the gas introspection. Joachim gave the idea, which is actually do ETH estimate gas calls. And maybe with that, we can kind of sort it out one way or another. The only problem is that these don't take into account previous transactions within the same block. So if I do something in transaction 1, and then in transaction B, I touch state that was touched in transaction 1, the gas estimation of the second one will actually not work. So we will need something like ETH, I don't know, estimate block gas, or I don't know, something like that, so that we can send an entire block and see how much gas the entire block takes to be processed, basically. If we can have that, then I'm positive we can fix this quite easily.
So my thoughts on this is that this already computes the gas. So we already put the effort on trying to pre-compute the gas which we want to use for this transaction. So I'm hesitant to roll that back because we already did the work. And also, I have another PR that is very recent. And the idea of this other PR is that we automate the gas calculations for all the tests, basically. And this will make it extremely easy for us to pre-compute the gas during the test execution. I would like to show that tomorrow on the gas benchmarking call. And if there's no hurry to mesh this today, I would wait for tomorrow for me to present that PR, and I think I can get you guys on board with this change. But yeah, I think the only question I have is this important to get it meshed today, or can we wait until tomorrow? I think that's my last question.
At least for the depth and Xcode size benchmarks, this is not an issue at all. They are already working, and in fact, I have been using them locally to get the 7907 benchmark results. So I'm fine on my side.
All right, thanks. Oh, so yeah, let's wait until tomorrow. I'll share a little bit on the other PR, and we can discuss that there. Yep, that's it. Thank you.
Perfect. Thank you.
Just one question for Mario. Regarding the binary tree, what would be the best way to at least start figuring out how to integrate and move everything that we have in our execution spec tests branch to the execution specs normal one? Should we have a call, or what's the best way to do this? Because we discussed about that, but nothing was done. And if a lot of things depend on binary tree, maybe we should start prioritizing that a bit more.
I'm not sure about the status on that one. I mean, we can set up a call if that's what you guys need. That's fine. Yeah.
Okay, I'll DM then. Thank you.
If there's a call, I'd like to be part of it, and also we should wait for Karim to be back because he's going to be interested in that. He's also working on the topic.
Yeah, if we can delay, because this week I'm going to prioritize Amsterdam EIPs. If we can delay and it makes it better for attendance, I think that's what we should do. Yeah.
Okay, perfect. Thanks.
Thank you. I think someone else had their hand raised. Maybe Damian. I can recall who that was.
Yes, that was me. Hello, everyone. I just had an organizational update. So as you know, Tanishq left Nethermind, so I'm kind of stepping up, and I'll try to keep my hands on the updates and bring ourselves up to speed with the binary design. Yeah, that's just it. That's all I wanted to say. Thank you.
Right. Welcome along, Damian, and thanks for taking over the Spanish work. Anyone else for team updates? Good. The agenda is quite packed. We won't have time to go through all of it, but I'll just go sequentially. If most of them are from you, Guillaume, so if you feel like some of them could be postponed to in 2 weeks, you can just say so and we can skip it and move along. So the
Yeah.
yeah, you want
Sorry,
to say
go
something?
ahead. Okay, I just wanted to say I was going to make a quick TLDR on the roadmap, but the roadmap is still being worked on. So I would rather like to skip this one.
Sure.
Then there was another one. Basically, okay, I would like to prioritize the one about using a smart contract to perform the transition, a system contract, and time permitting, do a bit more. But yeah, I would say that's the most interesting one for the time being.
Sure. So let's start with the proposal to use a system contract to store conversion pointers. That's the one, right?
Yeah.
All right, you want to take it along?
Okay, I changed the name while I was making the presentation, but yeah, the idea is that currently we have to keep when we do the tree transition, right? We go over every single account in the tree. For each account, we enumerate the storage. In fact, we enumerate the storage before we even take care of the account. So we need three things. We need the last account hash, the last storage hash that was processed, and just a flag to say that was the end of the storage processing. And the reason for this is because if the cutoff happens between the storage the storage enumeration and the account, we need to differentiate the fact that we haven't started enumerating the storage from the situation where we have enumerated the storage, but it got interrupted. And the next thing we need to do when resuming for the process for the next block is to just process the account. So you need three things. And excuse me. This approach has a few advantages. It also has some drawbacks, namely that currently those sorry, it's not the approach itself, but currently we store that in the DB. Like in everything I implemented, and presumably Tanishq and Karim implemented as well, it's stored as something that's not in consensus. And so it needs to be loaded from the DB. It needs to be stored at the end of the block processing. The advantage of this is that you can first compute the root hash and then store the transition pointers. You can start doing the transition for the next block before. Basically, because it's not in consensus, you can do that whenever you want and however you want. The problem is that you need to write some custom reorg logic if something happens, and this was notoriously difficult. That broke many shadow forks. So we were not I wasn't very happy with this, but there was no better proposal until this one, which is what Weyhan proposed for 2926. It's to save the pointers in a smart contract. And initially, I thought that's a good idea for 2926 for AT32, but you can't really do this because you can't really do this for a binary tree transition because you need to know the root beforehand. Yeah, at least those pointers were until now in the database were indexed by the root. So this is still true, but I don't think it's as much as a problem as I used to think, in the sense that it just enforces that the transition for one block is really performed before the state root calculation is. But once you have this context, that means it forces you to do the transition before processing the rest of the block. But that can be done. You can't really do it after. But that's honestly, that's not changing much. Like, the more I think about it, the more I realize it's not changing anything. The biggest advantage is that because it's stored in the state, it's visible in consensus, and so the reorg logic is that of just rolling back the block, rolling back the state, and this is quite easy to do. It solves also the question of snap sync, because before, how would you download the pointers during a snap? If your snap sync happens during the conversion, it's not really clear how you would do this. Here it's just about sharing the state, so that solves that problem too. And I think for eels, it's also going to solve the problem, because until now, well, we never really completed the transition test in eel, but they would have had to be passed out of band. Like, you need to create some custom logic to handle that. With this approach, not anymore. You just do the whole state export, state import, and you get the pointers as is. Yeah, I think that's pretty much everything. So one thing that's not in the slide, but the people who attend this call often know it's one of my pet peeves. We would have to go read the state directly from the contract, so not do any EVM execution. But anyway, I don't really know what an EVM contract would look like. I mean, I guess you could just call a contract, an EVM contract every time you update you process a block, but that would be extremely inefficient. So I think it forces that model where you just go and directly read the contract state, excuse me, without having to update to call any contract and to call the EVM. I don't think that's a problem. I mean, it never was a problem for me. I don't know if there's any dissent for this fact. But I think, yeah, it's an acceptable requirement. So yeah, all I need really is to collect feedback from the teams, namely Nethermind and Besu. We could do a quick implementation. I did code something for 8032 over the holidays. Excuse me. I guess I could extract this and finish the prototype, and then we would want to do a shadow fork. But yeah, once again, Karim is not here today, so we'll have to see with him. That's pretty much it. Is there any feedback? Okay.
Anyone has a comment for Guillaume? Thanks for presenting. Do you have a link to that presentation or that write-up somewhere?
Sure, yeah. I could share that. Here.
Okay. Anyone would like to comment? I saw a mic unmute. Maybe someone wanted to share something. All right. Fair enough. Let's continue then and give feedback to Guillaume. I think Guillaume, did you want to proceed with the next element on the agenda that you had? Otherwise, we can also give the mic to, I think, Han that wanted to discuss a draft EIP called temporary contract storage.
Yeah, let's give the mic to Han.
All right. Thanks, Guillaume.
Okay. Thank you. I'll be quick. So let me just share screen. All right. So I just want to quickly discuss on draft EIP. I mean, very early stage EIP called temporary contract storage. So the primary motivation is to disincentivize state bloat, and also it's also inspired by some of our previous state expiry ideas. And I guess this ideas was also discussed many months ago when we first did this state analysis. So yeah, I just want to briefly go through this, the general overview of this idea, and also get some early feedbacks. So a quick recap on the type of storage. So you have the memory that is scope per core frame, and then you have the transient storage, which is scope per transaction. And then you have the contract storage, which is what we are very familiar with, which persists forever, or at least until a state expiry scheme is live in protocol. Then you also have blobs, which persists up to around 18 days. But the thing about blobs is that EVM cannot access it, or it cannot read or write to it. So it's not very useful from the EVM perspective. So the general idea is to ask this question that says that whether we can have a storage that lasts for n blocks, right? Then we move on to the analysis that we did a few months ago. So a few months back, we found out that actually most of the contract storage, more than 60% of the total contract storage, were used only in a single block. So that means they, it can span many transactions, but they will only use in a single block and never access it, at least on chain, ever again. So, well, since we have this data point, then the question comes like, since most storage slots are ephemeral, what if we provide a temporary storage space? So that's the motivation. The general idea of how it works is that, again, there are many variants, but this is just one of the variants. So this variant uses a system contract, which basically we will be storing every contract's temporary storage in the system contract storage, right? So that sounds like a mouthful. And then we will also be introducing two new opcodes. So it's similar. The general semantic is similar to as a store and also as load. So here I call it TMP store, temporary store, or temporary load. So the difference is that you're not storing in. You're basically storing this key value pairs in the system contract, the specified system contract storage. And because we are storing for all of the contract address, so that means that there needs to be a key derivation formula. Here I just it's just a simple address and appended with the slot key and then hash it. So when you insert into the storage trie, you will rehash it again, like every other storage tries. So yeah, that's basically the gist of it. And the general guess semantics are, at least for now, is similar to sload and store. So the most important part is the clearing. So on a protocol level, we will say that, for example, every 6 months worth of blocks, we will be resetting the storage trie of the system contract. So originally we will have this storage tries full of contract storage or temporary contract storage. Then we will reset to empty root hash and begin from there again. So every n blocks. That's on a protocol level. On the EL clients level, most likely EL clients will have to persist this temporary storage for longer than this protocol parameter, because you have to deal with reorgs and maybe also have to deal with like RPC queries and so on. So yeah, that's the implementation detail. But on a protocol level, when you are trying to, for example, read a value from this temporary storage, if it resets, then it starts from 0. So yeah, that's basically the gist of it. So in regards to the pros and cons, so the pros is that, first of all, it wants to disincentivize state bloat. It tries to reduce the size of permanent contract storage. It does not solve the state bloat, state growth. It does not reduce the state size that we have, but it attempts to modify the user behavior such that if most contracts use this feature, then we effectively slows down state bloat. And then definitely the incentive to use this over the permanent storage is that this storage would have a cheaper gas model, because if it's the same, then nobody wants to use it. And in general, it's pretty clear and predictable, because we are expiring or deleting the temporary storage for all of the contracts every n blocks, and not just per, and it's not per address basis. I think on the implementation level, I think it's quite pruning friendly, because ELs only have to target one specific account, so not all of the accounts. So in regards to the disadvantages, so the parameterization is quite tricky, because how should we decide how long should we keep this temporary storage? Is it 1 day? Is it 10 days? 6 months? 1 year? Right? We have to find out what this number should be. And we will also be adding complexity to EL clients, because you have to handle this new class of state differently and efficiently, because potentially you will have to create a new database, or separate files to store this, so that you can delete them in one go. But there are also other details, like you have to store it in the history and so on and so forth. So I think this part would be most of the work. And again, you have to deal with reorgs and RPCs. This is also EL complexity. And in regards to unified tree or binary tree, I think this idea, at least given this variant, is quite tricky, because we are storing the storage in the same tree. So that means pruning becomes very tricky. So we have to handle it differently, or it may not work at all. So it's something that we have to explore in the unified tree format. So next steps, just a quick one. I want to validate if this feature is actually useful for applications, because if it's not, then there's no point moving forward with this. And also to figure out a suitable time window to store the temporary storage, and also to figure out the right gas model. So yeah, it's still at very early stage. So yeah, happy to have any feedbacks.
Cool. Thanks a lot, Han, for presenting. I have a few questions on that, but since we're out of time, I'll just leave them for a sync. Is there a document where we can share feedback or questions that you could share?
I have the slide for now, so I'll just share it in the chat. Yeah. Sure.
Guillaume, you raise your hand.
Yeah, I had a couple of questions. I guess first, like a comment, right, which is like for binary tree, like if it's like the fallback option you always have is to just like have multiple trees, right?
Yeah.
I guess the other thing is I think for any design like this, you probably want to have 2 trees, right? And like basically like clear them at alternating intervals, right? So that way you can guarantee that even if you make the storage like 5 blocks before a transition, it'll still live for 10 days or whatever, right? And then and then in terms of duration, like one natural kind of shelling point is like the 7-day level, or like a bit longer than that, basically, because that's the duration that like things like optimistic rollups are like basically that's the duration that the ecosystem already has some norms around, assuming that people are able to go on chain at least once that often. So that's like one place to start. I guess the question is like, when you looked at these situations where 60% of like user storage slots or whatever the number was were accessed in the same block, like, do you have any idea like what kinds of applications that came from, and like to what extent that's like predictably storage that lives for one slot versus like you don't know if it lives for 1 slot or 2 years?
Yeah, actually, that's a question that we have to figure out, because presumably most of the contract storage is like a mapping of like the balances. So if these are all the balances, then I'm not sure if the temporary storage would work. But if it's something else, then this feature will be quite interesting. So yeah, we have to figure it out.
Yeah, makes sense. I think with with balances, there's always the idea that people will use it, and then if some of your coins expire, you bring them back with a Stark. intuitively, right, the use case of this sort of thing is that like you use it to store information about events, so like DAO votes or like fraud-proof instances or auctions or like anything that happens. But like it will be like I would be really interested to know, like what the actual percent of storage is that is those kinds of things.
Okay, yeah, that will be next step. Yeah.
Good, thanks. We'll wrap it up. We're slightly over time, but thanks everyone for joining. This was Stateless Implementers call number 46. I'll be sharing the summary of this call, and we'll be tweeting a Twitter thread about the lines of the call. So thanks again for joining, and see you in 2 weeks for number 47.
Thank you.
Thanks.
Right. Thank you. Bye.
Hmm.